So the question reads, a load of mass 75 kilograms is initially at rest. So Vi is equal to 0 on the ground. It is then pulled vertically upward at a constant acceleration of 0.65 meters per second squared. So A is equal to 0.65 meters per second squared by means of a light rope. Refer to a diagram, ignore air resistance, and so on. Question 13.1, draw a labeled free body diagram for the load while it moves upward. Now, while it's moving upward, there's only going to be two forces acting on it. There's the force of gravity pointing down and the rope, so tension pointing upward. Name the non-conservative force acting on the load. So gravity is a conservative force. That means tension must be the non-conservative force. Next question, calculate the work done on the load by gravity. So, and they tell us that to move the block up 12 meters. So delta x is equal to 12 meters. Now, we can calculate the work done by any force by saying that the force times delta x times cos theta. So the work done by gravity will be gravity, which is mg, times delta x times cos theta. Now, the mass of the object, they've given it to us as 75 kilograms. So 75, and then the acceleration due to gravity is 9.8. Delta x is 12 meters, and then cos of 180 degrees. Now we're going to use 180 degrees because gravity is pointing downward, but the block is moving upward. So there's a 180 degree separation between that, or between the two forces, or between the two vectors rather. And so we're going to get that the work done by gravity is going to be negative answer, negative 8820 joules. Next question says, state the work-energy theorem. We will leave that out. And the last question, use the work-energy theorem to calculate the speed of the load when it is at a height of 12 meters. So work-energy theorem is W net is equal to delta Ek. Now I want to use F net times delta x times cos theta as my delta Ek. So W net is F net delta x cos theta. Now we don't know the tension, so we can't calculate the work done by tension or the force of tension and then subtract. So there has to be an alternate way. There has to be another way that we can do it. So if we look carefully, we notice that we've been given the acceleration and we know the mass. So we can use Newton's second law, which says F net is equal to ma. So we can say here that ma times delta x times cos theta is equal to delta Ek. Now the mass is 75. The acceleration of the block is 0.65. The block is moved up 12 meters. And here it will be cos of 0 because F net will be in the direction of the displacement. And that's going to equal half, the mass is 75, and then Vf squared. There is no initial kinetic energy because it was at rest at the beginning. So Ek initial is 0. Now we just need to solve for Vf, and remember we have to square root at the end because we are solving for Vf squared. So Vf is going to equal 3,95 meters per second.